Typical graphs you're going to see on this type of tests. Depending on the type of information that's presented or represented, you're going to see probably 3 separate types of graphs. And guys, you've used these graphs over the 11, 12 years you've been in school. Basically, you're going to look at maybe line graphs, bar charts, or maybe a pie chart, a pie graph. If you're comparing 2 qualitative quantities, you can put this into a scatter graph. It's basic plotting of points. That's where you see trends. Information trending upwards, speeds increasing, productions increasing, or negative slopes, where you're going to see a negative trend in data. A lot of times an XY scatter graph is used to portray trends over time. Is a quantity over time decreasing? Is a velocity decreasing? Is production increasing over time? You're going to compare 2 quantities and it'll be plotted. Make sure when you see one of these types of graphs, you understand the data. What's the data that's being plotted on your y-axis? What's the data on your x-axis? What's the relationship between these 2 pieces of data? You've seen all of these in your science classes, and as you see these graphs or charts, you should recognize, I know what this type graph is. I know how to read this type graph. Typical example of a scatter graph where you're comparing 4 different objects, temperatures over time. Again, you should be able to look at this, understand the 2 pieces of data that are being compared, and you should see trends, increasing, decreasing. Simple reading of graphs. Bar graphs are going to appear too. Usually a bar graph is used when you're comparing one quantity to some other kind of quantitative piece of data. You've also seen these in your science classes right here. Here we're comparing precipitation on specific dates for 3 separate cities. Without reading the question or the passage, you should be able to look at this chart and in just a really short amount of time figure out what is it they're telling you here, what's being compared. Pie graphs and charts, probably one of the first or simplest types of data representation you used, probably in elementary school. You'll use a pie graph when you're displaying the parts or the percentages of a whole. You've also seen these in your classes. Pie chart, breaking down part to the whole. 41% petroleum, 20% natural gas. A really easy way to show how separate pieces of data are related. You'll also see things like tables. You understand how to read tables. You might have diagrams as well. This is a chloroplast. Biology students, you remember this. You might have to identify structures or do some basic reasoning with a diagram, but they're all going to be very, very simple. Now, second type question, a research summary. In a research summary, you're going to be looking at or reading, what did a scientist find? What were the conclusions a scientist or group of scientists came to after researching a specific topic? You're always going to have to pick out variables in a research summary. Are the variables connected? Are they linked in any way? So what are you going to have to do to be successful with this section? First, as you're reading it, identify the variables. What are they talking about? What are the factors that affect this problem? You've heard these terms all through science, but you should be able to recognize, what is the independent variable in this research question? That's the one the researcher controls. They adjust the independent variable. Then you have a dependent variable. That's the variable that changes because the researcher changed the independent variable. The dependent variable depends on the independent variable. In any experiment, you're going to have controls, a part of the experiment that you keep constant and you adjust other part of the experiment. Hence, for doing the research summary section, again, as you're reading it, pull out what the variables are. What did the researcher adjust? What was affected by that adjustment? What parts of the experiment did the researcher keep constant? Identify the different variables. If there are graphs attached, I would suggest going to the graph first. What is the researcher talking about here? What's the topic? What variables are being compared or affecting each other? Third type of question, the conflicting viewpoint question. Again, you're going to have typically two different viewpoints, two researchers that have taken the same topic or question and come to different conclusions. Both conclusions might be completely valid. What you have to do is read both sets of research, understand how those scientists came to those conclusions, and then possibly compare, contrast, or maybe even make a decision on one of the two research methods. But you're comparing two contrasting viewpoints. In order to do this correctly, you have to read the passage well enough to understand, why did scientist A come to this conclusion, scientist B came to a different conclusion, and it's the same topic. You need to understand their reasoning. Understand the bottom line of each opinion. Why did this scientist say this? Why did this scientist say this? And what evidence do they use to support their claims? Careful reading is really important on this type of question. Some other strategies, general strategies for taking the test. Prioritize. There are going to be simpler questions. Within a section, typically the first questions are the easiest, and as you go through a passage, the questions will become more difficult. Remember, the clock is always ticking, so pick off the questions you know that are the simplest ones. Start at the top, work your way through. Logic and common sense go a long way. One of the problems students have is they talk themselves out of answers. You'll be surprised how often your first gut instinct is the correct answer. Don't talk yourself out of answers. Look for trends in graphs. Again, do you see a general downward trend? Is there a general upward trend? Before you even understand what the graph is talking about, see if you see general trends visually in the graph. ACT is really good at trying to intimidate you. Don't let science-y language fool you. Common sense, they're trying to throw you off at times. Don't let that happen. And read carefully. Again, this is timed. A little bit of pressure exists. You've got to work steadily, but you've got to read these passages carefully. And finally, again, trust your instincts. If you have a gut feel, a knee-jerk reaction for an answer, go with it. Odds are it's right. The one thing I could ask you to do that's going to help you the very most, practice. The more of these science section samples you can go through and work a full science portion of the test, the more comfortable you'll be, and you'll be really surprised. The more practice sessions you do, all of a sudden you're going to start to recognize the different type questions, the graphs you're going to see. Practice, practice, practice. Again, this will be posted on our Canvas page for ACT. There are a lot of resources out there for practice. These are 4 links you can go to for free, direct science section practice sessions. A lot of these, the first two are on the ACT website. They'll give you the answers and the justification for the answers. So, practice. So to recap, what are the three types of passages you'll find on the ACT? There's data representation, research summaries, conflicting viewpoints. How long do you have to complete the science section? You've got 35 minutes. How many questions can you expect on the science section? You'll have 40 questions. Real quick, ask yourselves, true or false? The science section of the ACT will require you to remember every piece of information you have heard in science class over the last 11 to 12 years. False. Your scientific skills will be tested, not how much information you've memorized. True or false? I should make sure to answer every question on the science portion of the ACT. Absolutely true. When your proctor calls 5 minutes remaining, if you're not finished yet, go directly to the end of the section and bubble every question up to the point that you stopped. Then start answering logically. There are no penalties for wrong answers or guessing. A blank answer is wrong. Do not leave anything blank. If you want to review this PowerPoint, it's going to be on our West Wilkes webpage and hopefully loaded to Canvas. And again, practice. And as much emphasis as we put on this test, do your best to relax. You can all do this. It's not difficult. Know the tricks and do well. Thank you very much.